Morning, everyone. Hi, Azra. Hi, Logan. Hi, Ava. Hi, Ryan. Hi, Kimmeline. So, just as a reminder, this is a review of the notes before I post the DNAQ. The last one you're going to be doing. Morning, Jake. So, it's not going to be as long. Probably like a 10-minute review, and then we'll post the quiz. I'll show you my screen as you do it, and then probably just end it as other people take it who aren't watching. Alright? So, today's agenda, again, if you need to hear it, because you're late, like Jake Rainey is every morning. Kidding, Jake. Review DNAs 1 through 6 from sheet number 26. We're going to take DNAQ 26 XL, extra large. It's worth 2, because we have last week's and this week's combined together. And then just make sure you have Seeing Stars completed, and when I return it, if you want to revise, work on a revision. Pretty much people are losing points a lot of the time in the first couple questions and the last couple questions. Either not giving me enough information, or their own analogy, or their own connection in the definition questions, or at the very end they aren't referencing actual stages of stars in their life cycle. They're just kind of saying stars blow up. Okay, true, but there's stages prior to that. Alright? So, DNAs 1 through 6. I posted this yesterday. Told you on Remind it was posted Monday from May 4th all the way to Wednesday. Yesterday, May 13th. We'll kind of go through each of them. If you have questions, please ask. Email, Remind, those of you in chat right there. Alright, so DNA number 1, I asked what is the habitable zone in reference to a star. People doing App A, you should know this very well because you need to do this for your GSA assignment. Those of you not doing App A, you needed a little more time to maybe look this over. People in App A could have helped you. And so, I'm trying to figure out a good zoom. The habitable zone of a star is the area or distance that you extend from the star where there's enough radiation to have liquid water on its surface. That's also a key right there, that a planet has to have a surface. You can't really just have a gas giant with life on it. As far as we know, that maybe could change. You know, some scientists think there might be life possible in the upper parts of Venus's atmosphere, or maybe even Jupiter, but as far as we know, life doesn't exist in the clouds, or hasn't originated in the clouds, and so you need liquid water on a surface. Okay? If the star is larger and hotter, the habitable zone obviously is further away from it. Okay? When I mean a larger and hotter star, I'm saying like a blue supergiant. Right? A blue supergiant is going to have a habitable zone that is farther away compared to our sun's habitable zone. Alright? If a star is smaller and cooler, like a red dwarf, remember we have 3 kind of like main sequence kind of stars, or young adult stars. We have red dwarfs, yellow main sequence, and then we have blue supergiants. Blue supergiant, larger and hotter, means the habitable zone will be further away. And then if it's a red dwarf, smaller and cooler, it would be closer. So Proxima B and Proxima C around Proxima Centauri, they could be closer to their star and still be in the habitable zone. A star who's orbiting Rigel or Vega would have to be further in the habitable zone. We're actually kind of near the edge of the habitable zone for our sun. So Venus is too hot. Any water on its surface evaporates. And that's why it has such a large atmosphere. We think its oceans did kind of like almost boil away and form that massive atmosphere. Mars on that edge of habitability. It's still a little too cold because it has no atmosphere. If it was geologically active, it would have had liquid water on the surface. But it has no geological activity as much as the Earth, so it has no magnetic field, so it has no protection from the sun's charged particles. Like how we have protection, our magnetic field and our thermosphere. So Mars doesn't have that protection, so no life. But that's why it's a question mark, because it's on the edge of the habitable zone. If you go further in the asteroid belt out to Jupiter and the outer planets, there's not enough thermal energy. Unless you're on a moon around Jupiter, but that's due to friction and not due to the sun. So there could be life possible past the habitable zone, but you would need a very special circumstance, like friction of Jupiter pulling on Europa's core, that friction causing an ocean under the surface. That could be possible for life. But focusing on the habitable zone being the area from where a star can have liquid water on its surface. Any questions on that one? No? Come back if they come. Number 2, asking you what a spectra is. A couple people took to Google and they just used the definition they got from dictionary.com. Can't wait to see how this turns out for you on the DNAQ, but a spectra, yes, plural of spectrum, but our definition is the rainbow produced when light is refracted or split based on wavelength from a source. So you're using either a prism or, in the GSA's case, for people doing App B, you use a CD or a DVD or a game disc. And the discs have very special grooves and surfaces on there so that a laser can actually read the different parts of the disc, and that's where information's stored. So CDs, DVDs, and game discs are designed to be able to refract a laser light to store information, right? So we can use that to point light at it and refract white light, okay? White light being all the colors, Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet, okay? If you did a good job, or if you had really good technology, you would see black lines pop up inside the rainbow. And those black lines would actually be specific elements or compounds that are coming from or within the light source that are absorbing light at that wavelength. Remember, this is high energy, short wavelength, violet, and then red is long wavelength, low energy. Okay? But because these bands happen at very specific points, you can think of light as a fingerprint or a barcode that you can use to identify things. So if you find a spectra of the sun, but from another star, that other star would be like our sun, a yellow main sequence star. Alright? So they use for identification, and they're a rainbow that's produced by refracting. Think of it as like a fingerprint, right? Number 3 from last week, App C, problems in interstellar travel, going from one star to another, right? I said Proxima Centauri because it's the closest star. So the closest star, and showing you how much of an issue interstellar travel is, okay? Because the distances are ridiculous. Okay, 4.3 light years from our solar system to the Proxima Centauri system. Even if you could travel the speed of light, it would take 4.3 years to get there. So some people then were like, okay, even if you could travel the speed of light, then that means my second point, life support, is a big issue. You need the food, you need the water to actually take 4.3 years to get there. Also, you have to be able to withstand 4.3 years of cosmic radiation, which is not very good for your DNA. Okay? So, long travel time plays an issue on life support. Alright? In addition, once you get to Proxima Centauri B, Proxima B, to send a message back to Earth, it would take another 4.3 years. So it would take 8.6 years to send a message back and forth. Now that's much longer than it used to take for even letters to get sent back and forth. All right, before the internet, even in the Middle Ages. All right, even if you could write. All right, so large lag in communication, large lag in travel. All right, even if you could travel the speed of light, because the first issue, distance is too big. There's a lot of space in space. Long travel time, slow communication. Those are the big issues. All right. So then people in App C, they were thinking about, well, either we send an unmanned, a no-person probe through breakthrough Starshot, which would take, hundreds, if not thousands of years to get there. But then you would have to use some kind of warp drive. You would have to go faster than light. And that would have to be the real solution to this problem if we were ever going to go beyond our solar system. DNA 4 through 6, talking about seeing stars, the different types, and the effects of a star's aging. What is a star? In our definition that we use, it's a massive collection of gas, a spherical collection of gas that undergoes fusion at the core due to gravitational pressure. So gravity is pulling hydrogen into the center. As hydrogen gets pulled in the center, no room for it to go until it goes into each other. When you have two protons together, instead of just the one, you go from hydrogen to helium. That releases energy, and that's called fusion. Okay? There's different ways to look at and to categorize stars. Proxima Centauri is a red dwarf. The Sun is a yellow main sequence, sometimes called a yellow dwarf. Okay, Betelgeuse out in Orion is a red supergiant, massive star. Right? Rigel, I think, is a blue giant. I'm not positive. I'd have to double check that. But it just goes to show you that there's different colors and different sizes. So size and color are the big ways you can identify and categorize stars. All right? Temperature is also related to color. Red is the coolest. Still incredibly hot, but it's the coolest. Yellow's in the middle. All right? Blue is incredibly, incredibly hot. All right? So yes, the red supergiant is actually a little cooler, but it's enormous. And so that extra size makes up for the lack of heat. Still higher temperature. Now, kind of talking again about fusion and gravity, it's a delicate balance. All right? If one outdoes the other, then you're going to have a change in the star, right? You sitting in your chair, you are stable because the forces of gravity and the normal force in your chair are at equilibrium. If you upset the balance, something's going to happen. If the chair gets weak, you're going to crash through the chair and land up on the ground. Okay? Gravity wins the battle. If gravity for some reason changes on the Earth, normal force will allow you to push and you'll be able to float, right? Because gravity has lost the battle. So a lot of it is depending on gravity's strength and change, but then also stars are producing energy, so fusion going back and forth. The electromagnetic radiation from fusion, which is powered by gravity, working against gravity, right? So it's a very delicate balance here where hydrogen is being fused into helium. The size of the star is stable, not changing, because the force of gravity and energy from fusion, the radiation from fusion, are balanced. As stars age, they fuse larger and larger elements and become bigger stars. They start fusing helium, they'll start fusing boron, they'll start fusing carbon, they'll start fusing oxygen. And you can get all the way to atomic number 26, and that's iron. There's not enough gravitational pressure to squeeze iron into other iron and to make a bigger element. Not enough energy. There's too much repulsion between all the electrons and all the protons involved in an atom of iron, and so you won't be able to fuse them. And so then seeing stars, I asked you in the first evaluate question, how do you get more and more elements? You got to have more extreme sources of energy, like supernova or two neutron stars, the dead cores of stars left over from supernovas that didn't go black hole. If they come together, you can get heavier and heavier elements. So you get gold and plutonium, or really uranium. Plutonium was made in the lab. Any questions on this? It's a very delicate balance. As you fuse larger and larger elements, the stars become bigger because fusion is pushing further and further out. But then eventually they'll reach an equilibrium with gravity again. And that's where you get a giant. Either a red giant or a blue giant. Okay? Eventually, you run out of those elements, fusion stops, gravity all of a sudden wins and crushes everything down to the center. In larger stars, it's very explosive. In smaller stars like the Sun, it's kind of, I don't want to say gentle, but it's less extreme than a supernova. The outer layers just kind of blow off. Makes what we call a planetary nebula. Nebulas are just gas in space, collections of gas. Alright, so the last one. And then I'm going to post the quiz. Our Sun is a yellow main sequence star that will progress to a red giant, start fusing helium, and then lose its outer layers into a planetary nebula as fusion ends, and gravity will collapse it into a white dwarf. This will happen in about 5 to 6 billion years from now. The Sun's about 4 to 5 billion years old now. So the whole life cycle of this Sun, our star, is going to take about 10 to 11 billion years. Okay? The larger the star, the faster this whole thing happens. So let's say Betelgeuse will take a fraction of this time, even barely make it to a billion years old. Okay? Proxima Centauri, a red dwarf, will burn much slower through its hydrogen, and therefore could go on for 20, 30, 40 billion years. So it depends on size and how much hydrogen you're burning and fusing up. Right? The more massive stars age faster. Smaller stars age slower. Again, it's like a campfire. The bigger the campfire, the more fuel it needs, and the faster it's going to go through that fuel. A small campfire, or maybe like a little grill, right? That can go for a very long time. You keep feeding it charcoal. Alright? Our Sun is a yellow main sequence that will progress to a red giant. Then it will become a white dwarf. A lot of people in the evaluate section miss that part. They miss this red giant part. I want you to tell me that was going to be a red giant before a white dwarf. Alright? I know it said the end of the star's life, but I mean this is also part of the end because we're not there yet. Alright? There is not enough mass to go supernova. You need about 10 solar masses to go supernova. You need about 30 solar masses to go black hole. So stars that are 10 to 20 mass greater than the Sun, they'll go supernova, end up as a neutron star. Neutron stars are so incredibly dense. I think the common analogy is a teaspoon of it would fall through the Earth because it's so incredibly heavy, so incredibly dense. Because the electrons have now combined with the protons to only be neutrons in a neutron star. Pretty extreme. I mean, so that's a brief review. If you have specific questions, now is your time to ask. If you've been in chat, or you're just kind of watching along. I got my weekly email from Cody Fretz on what time the quiz is going to be posted. I think I'm going to take a screenshot of my last email and send it to him. Is that kind of mean? I'm not trying to be mean, just like, you know, check your email, Cody. Alright, so if everybody's good, do it. Everybody's good, I will post the quiz. Refresh if you do not see it. If you are Nikolai, stuck in California, or Miss Kildoff's group, check email in a couple minutes. What planets did you see? I know Venus is still out pretty early. I know Mars, Jupiter, Saturn, they're going to start coming out. Yeah, they're going to start coming out this morning. Early morning. You woke up to see it, Ryan? I've been trying to get pictures of Venus earlier during distance learning, but I don't got a nice enough camera. It looks better in person. So yeah, dude, I mean, as the summer goes on, those planets will come out during the nighttime, which would be awesome. So if you're not seeing them now, you don't want to wake up early in the morning, you can check them in the summer, but do it now. I mean, morning is probably the best time to look at stuff in this night sky because the moon really isn't out and the Earth is progressing into sometimes debris fields from comets, and that makes some nice meteors. Very cool. Also, while you guys are taking this, I know it's going to take a little longer because it's double the questions. There are 2 questions at the end about one thing that went well, one thing that didn't go well during distance learning. So fill that out at the end too. I made it required. You don't like the true or false question? I mean, it's a... What? You feel like we never went over spectra and being unique to their light source or not. Jake. Might be a mess. This might be a massive hint. So all of you who are also listening probably benefit. Are your fingerprints the same for anybody else? I mean, technically, there could be some similarities, but is there anybody nearby with the same fingerprint as you? Do different items at the stores have the same barcode? Think about what an analogy would be, right? Unique means only, right? You are unique. You are the you and only you. Ava's just like, what? If you get to that part, Ava, think about barcodes and think about fingerprints. And you talk about spectrum, the true and false question. Question asking what force will increase in pressure. Do you mean the force increasing while the star expands or when the star is done expanding? Let me find that question. So the question is, what force will begin to increase in pressure when a star increases in size with age, right? That's the question, Hike. So what I'm asking there is, as it's getting bigger, what force is winning? So not when it's done expanding, it's while it's expanding. I just forgot it was up. Minus 5 G-bucks for Jake. So did you hear my answer, Hike? I'm talking about the force as the star is expanding outward, not when it's done. Alright. Well, you're not doing G-bucks because you just lost all your G-bucks. So Cody sent me an email April 30th. What? That was... Yeah, that was DNAQ 25. What time is the quiz going to be posted? Around 10:30 like always. Today. Good morning, Mr. D. Do you know what time the quiz is going to be posted? Like, always means like I'm going to follow through on that all the time, right? It's a big difference. Did you ask a question and you got tripped up? Rainy? Let me double check. Sometimes I make a mistake. I'm marking the right one. No, that one's good. One of them was marked wrong. Oh, come on now, guys. One of them was marked wrong. Usually, if no one gets 100, it's a mistake on me. So I'll give it a second. It might refresh. There you go. There were 3 100s. Well, since this is the last one, after a few days, I might just return all the answers, since we're not really... You don't know if you guys did so bad. A 10 out of 12 is still an 88, I believe. We'll check the math. 10 out of 12 is an 83. If you guys want... The whole thing on how revision works is you see the score you get back in Aspen. I'll tell you what to refocus on, and then you can retake, right? If I have any like really bad low scoring ones, I'll throw them out too. Right now, it's Hike's question that only 7 out of 16 people got right. So when a question's really bad, clearly I made it confusing. I usually throw them out. So instead of out of 12 points, the quiz would be out of 11. Just won't count it. So we'll see if that's anybody. But again, we did get people who had 300s, so they're able to see through the confusion. And a lot of you need to stop complaining. Azra, you got a 12 out of 12. Hike, you got a 12 out of 12. Rainy, you got 11 out of 12. Downey, we may have to double check some stuff. I think you overthought here and there. Ryan, I think you and Downey overthought in certain spots. I told you that there's like a few second lag on stream, so when it submits and when you see it, it's not going to be timed up just right. So I shouldn't even be showing it to you. There's a lot of 11s. That's good. Not great. It's not perfect, but, you know, could be worse. Eight out of 12 is a 66. 67. 7 out of 12 is a 58, so you want to get that 8. So most people have passed. The large majority have passed. And I think it shows in certain weekly sheets too, when you guys get 12. I can keep doing that. It shows. I mean, Azra, you remade the notes. Hike, you took very good notes. Rainy took okay notes. Downey, you took great notes. Just a little surprising. Yes, you passed. You at least passed. I think the average is a 10 right now. Usually as more people take it, the averages go up. So the average right now is a B. That's good. The median is a B. That's good. Maybe I'm just really good at sitting still. It's because I opened up a link for a meet. And when Meet tries to use your camera from the system I use, the program I use, it freezes the camera. Because you can't have, I guess, 2 different software using the same webcam, because then it causes issues like this. So the fix is obviously to stop and start the camera, which means I gotta start and stop the stream. We're almost done. There's no point. So talking about moving your mouth, maybe I'm a ventriloquist too. I do have lots of finger puppets. I miss my puppets. I should have taken them out of school. But I mean, I got Sagan here now. Where's the rest of my friends? Where's Einstein? Oh, I am Einstein, but you can't see it on the screen. I don't think. See if it comes up. Yes. And there's Newton. We'll talk Einstein and Newton next week. Einstein and Newton for gravity. Obviously, we'll have Fun Friday next Friday, or the Mighty Meetup. Teacher PD day again on Wednesday, so you guys have school Monday, Tuesday, Thursday, Friday. Friday's nothing new. Friday's a Mighty Meetup, do revisions. So if you didn't do well on this DNAQ, this last DNAQ, you're welcome. You can revise it next week. I need more scientists. I should just get gifts for the ones I have for finger puppets. I wonder if there's any famous geologists. We're gonna have to do Earth towards the end of the year. Bye, Townie. So most of you are probably good. If you get stuck or you have questions, email them, send it through Remind. I'll help you out. Good luck in math. Good luck in algebra. Don't forget the quadratic equation. Have a good Thursday. Have a good weekend. See you guys on Monday.